Hey guys, it's Will. Today I'm going to show you how to code on cloud GPUs using either Jupyter Lab or VSCode, or even connect your own local VSCode. The advantage to doing it this way is that you'll be able to get a fresh new environment in a few seconds and then start coding, and then from there, add in GPUs, install whatever you want, and be able to code pretty quickly. So first, to get started, you just go to lightning.ai here, and then click on Launch a Free Studio. And then this will ask you to sign up. And there's no credit card required or anything. Once you sign up, you will end up in a studio just like this. So this is free. And you can see that I'm running on a CPU, for example. Now, I can run on other GPUs and different things, which I'll show you in a few minutes. But this is just like your laptop now, right? I have VS Code running here, and I'm just printing this. I can also run using Jupyter Lab. So if you prefer notebooks or Jupyter Experience, then you have that here. So I'll show you that in a few seconds. And here you go. You can just create a new notebook. We'll call this Hi. And you're good to go. Now start doing what you're going to do. Great. That's it. So everything's automatically saved for you. Now you have different apps in the studio. These are two that I showed you, VSCode and Jupyter, right? You can, there are other apps that I'll show throughout this, and you can install your own apps as well. So I prefer to code through VSCode personally. And sometimes I don't necessarily want to use the browser. So if I don't want to do that, I can just connect my own local VS Code. So I can say code from local VS Code. I can copy this, and then I'll just go ahead and create a new one here. And now I can just paste the command that I just copied here. So I just said add new SSH host. I press this. I press enter. And this takes about 3 to 5 seconds to set up very quickly. And now I am using that remote studio, but I'm on my laptop currently, so I don't need the browser to be turned on anymore, right? So I'm here. This is the studio on the browser, and this is my local VS Code connected to that studio, right? So I have to click yes. And then if I create anything or write any code, you'll see it immediately reflected in the browser as well, right? So anyway, okay, so now that I showed you how to do this, I'm actually going to use the browser for a little bit, and then we'll come back and code it locally. So that's kind of all it takes. All right, so this is really for any kind of development. Really, it's designed for AI and machine learning because you have GPUs and a bunch of other things, right? So I'm just going to run this. You have Python hello world here. You have the terminal. You have a standalone terminal here if you want as well. So I can kind of just run things manually, right? And you have full control. You can install whatever you want. So let's say I want to use something called Cause, right? Cause is this like silly program that's not installed on here, but I can just go ahead and do that, right? So I can install this. Great. And now I can use it, right? Cause just kind of, hi. Okay, so now this is installed. When I turn off the studio and turn it back on, everything that I've set up will stay there. So it's a persistent cloud environment. By persistent, we mean that all the dependencies, all the files you've put on here and everything else are available whenever you restart it or even change GPUs. Okay, so, all right, this is kind of like a boring example. Now, if you're in AI or ML, you're likely going to be, I don't know, testing new models, debugging, prototyping, that kind of thing. Just to show you how some of this stuff works, I'm going to paste on here PyTorch Lightning, right? PyTorch Lightning is our deep learning framework to fine-tune and pre-train models, right? It's been the standard for doing this for many years. You can use any open source model, or your own, right? So you can bring in models that are PyTorch, could be OpenAI, could be Hugging Face, doesn't matter. Drop them in here, right? So you could like bring yourself dot model equals, I don't know, bird or whatever you're going to use in here. And then you define what's going to happen during the forward pass and then the training step here as well. This gives you a lot of control. So you have full control over how you're going to fine tune and pre-train. So I'm going to run this thing right now. And this is going to run on the CPU specifically. Now, the workflow that I recommend is that you start first training or debugging or doing your code on a CPU so you can kind of profile how things work, right? So I see my CPU, RAM, everything's good. before you go scale to something more expensive. Now, I want to run on a GPU, so I'm just going to go ahead and pick this A10G, for example. So you get 15 free credits with the platform as well. This means you can run roughly 22 hours of T4 GPUs and probably around 9 or 10 hours of an A10G as well, right? And okay, so I'm going to just Control-C this thing real quick because I don't need it. If you want to start a brand new studio, it's very straightforward, right? I just type in studio.lightning.ai on the browser, and then that just creates a brand new studio. So this is by far the simplest, fastest way to get an online environment very, very quickly that's persistent, and you can prototype. And from here, you can really scale, right? So you can do a lot more than just coding. This is kind of just the beginning of this, right? Okay, my A10G is ready, so I'm going to switch to it. And if you notice, nothing's really changing here. It's exactly the same code. Everything is the same. I've got these new metrics up here, though. Yeah, so my connection did cut out, but I can just kind of reload it, and then it should basically connect again. All right, so now it's back, and now my local VS Code is still connected to the studio, even though under the hood they're different machines now, which is great. So again, you don't have to mess with like environments or any of this stuff here, right? Okay, so remember Calce? Well, you know, it's always going to be available in your studio now going forward, right? Hi. And if I go to the other studio that I started, this is a brand new, fresh environment. I don't have any of that stuff, right? So it's not installed. So it's like you got a brand new laptop, basically. Everything's set up from you. So this is like the fastest way to create something new, a new environment, do whatever you want, prototype. If you like it, keep it. If not, delete it. It's not a problem, right? Okay, so Calce is working. I'm going to just run this on a GPU now. I just press play. And if you haven't tried PyTorch Lightning, this is kind of one of the magic things that it provides is you don't have to deal with like changing your code for different hardware. So we were the first ones to introduce this ability in 2019. And today, through this trainer, so if you've seen this trainer in other frameworks, this is kind of where it's coming from, right? So this is the world's first trainer. It's also the most robust and scalable trainer because of that. So you can actually go to even multi-node, and some of the world's largest models today are trained using PyTorch Lightning specifically. And you notice why, because it's very simple and it just 100% works now. It's been a few years of it like being production ready, so it works really, really well. However, the studio, you can run whatever you want. You can run JAX, TensorFlow, your own PyTorch code. We don't really care, right? It's up to you. Okay, so this thing is running. Now, something that I like to do usually is a hyperparameter sweep before I go scale things. So in this particular case, like let's say I wanted to train this model, right? Well, before I go do that, maybe I want to change somehow like tune the learning rate, right? And I'll show you what I mean by this, right? So let's say and you guys can go duplicate the studio here, so you can see an example of this, right? When you find the studio templates, you just hit run, and then it basically forks this, and then you have a full copy of everything yourself. So if I run a hyperparameter sweep, let's say I'm training one model, and the learning rate is how fast that model is going to learn. So on the left, you have something where it has a high learning rate. So sure, like the loss drops very quickly, so theoretically it could finish very fast. However, the loss doesn't really go all the way to the bottom. Maybe this orange one would if we let it run longer, but it actually won't give you the best performance. Now, if your learning rate is too slow, you'll see kind of this blue curve up here where like it just takes forever to go low and low and low. So, you know, when you're training something for like 10 minutes or an hour, it's really not a big difference. I don't know if I'd waste a lot of time on this, but if you're going to do stuff over multiple days or months or even multi-node, you definitely need to do a sweep for like a few hours to like understand which learning rate gives you the better curve, and then run that for like the longevity of the actual thing. That's right. So here, the training itself, probably this is the one I would pick, whatever gave me this one, because it drops the loss fairly quickly. And it's also the lowest loss, right? So I know that I probably wouldn't necessarily need to spend a lot of money on this because I can probably cut it out earlier. So how do you find that? Well, you can experiment yourself or write something like a sweep, right? So we're going to do that here. So in Lightning, there's no special syntax to do a sweep. It's just a for loop over kind of what you want to run. So the studio that you're on has an SDK attached to it, right? And you can also use this outside of Studio. So if you're building pipelines and that kind of stuff, you can do that. So I can reference a studio here. So you grab a reference to self, basically, which is a studio. You use this plugin here called jobs, which is this guy here. And then I'm just going to search over these three learning rates, 4, 3, and 2, right? And then I'm just going to for loop these, and my script is called main.py, and I need to make sure that I can take a learning rate argument, right? Right now, I can't really do that. So if I run this, right, if I say main.py, and then I say lr1, it's going to complain that it doesn't know what lr is, right? So you need to, okay, well, I guess it didn't. Does it? Yeah, it definitely does not. So, oh, I see, yeah, okay. So here's what I need to do, right? I'm going to actually add the argument parser to this, and there are many ways of doing this. I just prefer this one. From import arguments parser, right? And then I'm just going to put this into a main function, which is totally optional, but it's good practice. And notice here, I'm using like a VS Code extension called Vim. So once you install extensions into your studios, they're available in all your studios, right? So if I go to this other studio here, I can still use Vim here because I've installed it globally for all my studios. And if I code for my local, I have all my local extensions that I normally use, right? So if I'm here, then I would have like Copilot or whatever else I'm using locally as well. That's also available in the studios. But okay, so I prefer sometimes to just code locally like this. So again, this is my local VS Code, but the code is actually on the studio on the cloud. So it's a remote server right now. Okay, parser, I just do arguments parser, and then I'm just going to add an argument to it. Add argue. It's going to be lr, and then type is going to be a float. And that's it. And then parser.parse args. Okay. So this is going to give me a learning rate. This is going to give me allow me to push parameters into the script, right? So I'm just going to open this terminal here. I'm going to maybe make this thing a little bit bigger. Okay. So let's say Python main.py, and then let's just make sure that this is currently working. So, okay, now you see that it gives me the arguments here. lr equals 1, and I can pass that in, and then everything should work. Okay, well, that argument is not actually being used anywhere, so we need to actually pass it in somewhere. So we're going to pass it into the model, like the fine-tuning sequence. So here, I'm just going to pass in, and I'm going to default this to whatever it is today, which I believe is this. Yeah, okay, this guy. And then I'm just going to register the argument here. Okay, and now I can just pass that in here. So I've parameterized the script. This is called a hyperparameter. It means that it's a parameter for the script itself. So now what I want to do is I want to run the same script here multiple times in parallel. That's called a sweep, to figure out which learning rate is the best one, right? All right, so this is all set up. Now my sweep script is here. I'm just going to name that so it's clear what it is. And I'm just going to try three different values for this hyperparameter. So it's 3 learning rates. And these are kind of like 1 order of magnitude off. Usually this is kind of how you would do this, right? From experience, I know that, well, we probably want to actually try another one that's like faster. So this is a super fast one, and this one is extremely slow. Probably one of these two will be the best one, right? Okay, so I'm going to call this sweep Feb 20 and 13 is the time I'm submitting this. I'm going to use an 8NG to do that, right? And now I'm just going to run this sweep script, and that's it. Now the sweep script is going to take my current studio, and then, well, the job is, sorry, it's going to submit 4 different jobs, 1 job per per value of learning right here. And you see that they give me kind of the links to all of these, right? If I go back to my studio, I see the 4 jobs here. So each job, a studio job, what it does is it forks the studio environment fully. So all the dependencies, files, code, everything, and runs them in their own machines. So now I've got 4 versions of the studio running in each of its own machines. So I can actually test how the model will converge under different learning rates, right? So this gives you scale. So studio is not just about coding interactively, it's actually about scaling out. Once you've set up an interactive environment, you can then just blow it up, right? You can spin up 100 versions of it. You can also do multi-node training, which I covered in a different video. and many other things, right? So in this particular case, I'm just going to keep it short and simple. So I've got 4 jobs. They're all going to be running on their own A10G machines. And that's great. So while that's happening, why am I doing this? Because I want to find the best learning rate before I go scale up to like an expensive machine. So I'm going to go, I should wait until that's finished before I do this, but for brevity, I'm just going to do this right now. So I'm going to scale to a machine with 4 GPUs on it now. Now, normally, before you do this, make sure you have debugged on a CPU and then debugged on a 1 GPU machine, and then you can go scale to multiple GPUs. If you've never ran multiple GPUs, it's probably because you don't have the right tools for it, right? If you're using just regular PyTorch or something else. One of the advantages of PyTorch Lightning is that it can just scale no matter how many machines you have automatically and how many GPUs are there. So once this studio gives me the 4 GPUs, which it's there, takes a few seconds. Notice that I have 4 little bars up here for the 4 GPUs. Wait for this to be fully green because it's setting up everything for you. And once it's ready, then I'll start running again. Now the jobs are still going, right? I haven't done anything to the jobs. In parallel, these 4 jobs are kind of running on their own, and I can see the machines here, right? I can see what's happening. Now this script is very short, so I suspect that these will be very, very fast to complete. So these are still setting up, 1.5 minutes and so on. And okay, let's see. Okay, so this one is using the learning rate 0.01, right? Now I can SSH into the machine that's running this job to make sure everything's good to go, right? So here I'm in that machine and I can just monitor things. This is not an interactive environment. It's really for debugging and understanding what's going on. This is also how you run things in production, for example, when you develop and then you want to scale out. Okay, so now I'm going to run the script again. So far, what I've done is I've gone from CPU to 1 GPU. On that GPU, I made sure nothing failed. Then I submitted a sweep to find the best learning rate. While that's running, I'm switching to a more expensive GPU machine to do multi-GPU training to speed things up. This is already probably 4 or 5 times faster. So think about it this way. If you've configured a model correctly and you're adding enough data to it, so setting the right batch size and everything, if my model takes, I don't know, 32 hours on 1 GPU, if I go to 2 GPUs, what you want to see is that it takes 16 hours now. So you cut the training time in half because you're using 2 GPUs. If I go to 4 GPUs, I expect it to go down in half again. So that should be 8 hours to do this thing, right? So it's roughly 4x faster. You can do the math. If you want to continue scaling and go to 8 GPUs, 16 GPUs, 32 GPUs, 64, you'll keep cutting the time in half and half and half. You can do that here by using the multi-node app here, which I have different videos for. So I just install this and submit this multi-node, right? And then that will continue to scale infinitely. So in this case, I'm actually doing the training. And before I go scale this up, I can actually go find the best learning rate here. So normally you need like an experiment manager or something to do that. In Lightning, you have a few built-in versions, which I'll show you in a second with Tensorboard. But if you notice, this model's training on the 4 GPUs, right? Now, I wouldn't scale this up yet to multi-node because I see that 1 GPU is not being utilized correctly, right? You can bring this thing out on its own. And I have it here, which is great. And then I'm good to go. Cool. Okay. So in this case, I definitely want to wait for those jobs to tell me which one's the best learning rate. So let's actually go and see what those are. I can go here in the file system. I can go up to jobs, right? And I see the ones that I submitted just now. So these 3 here, right? So I'm just going to link them here. Okay, so I'm symlinking here. Great. And you see that I brought over all of the experiments that I'm running right now. So I'm running 4 of them. And if I go to my Tensorboard, so this basically runs Tensorboard on the studio. And I'm able to take this Tensorboard here. Great, you see all the experiments here. And then I'm able to actually share this link with anyone. So anyone can actually see it right now. Tensorboard, the experiments that I'm running. And then, I would let it run, and then I would find an actual learning rate that I liked. And yeah, so I'm just showing a few kind of more advanced uses of the studios here. I'm going to turn off these jobs because I don't need them to be running. So this shuts down all the 4 independent machines. And then I'm back to kind of my studio here. Now, let's say I'm like pretty happy with what's going on. If you notice, when I ran this this basically started running on the 4 GPUs, right? So I can keep iterating on this, and that's fine. I think like as long as you're happy with how the model's doing, I would probably only be on the 4 GPUs when I'm training something for real or like running something long term. And otherwise, I will probably switch back to a CPU here and then actually go ahead and just continue developing and debugging on the CPU, right? Because I don't necessarily need to be spending GPU hours or wasting money on kind of just coding and you know, run-of-the-mill development before I go start to scale up again. So this is great. Now, if you notice, the other studio that I started automatically went to sleep. If your studio is inactive, so it's not running code or anything, it automatically goes to sleep, which saves you a ton of money. You can see the one that I'm running on right now. It's going to be switching back to a CPU machine pretty soon here. And yeah, and I can set up as many of these environments as I want. You can keep them around forever, and then you can delete them when you're not using them. And yeah, that's it. Okay, switch to CPU, and I'm good to go. So now I can continue developing the CPU. But yeah, I just wanted to give you a very quick high level of like one of the simplest ways that I think you can get an environment on the cloud with CPUs, GPUs, and connect to it from your local VS Code, and be able to code from using Jupyter Lab or VS Code as well. And again, you can start a new one by just typing in studio.lightning.ai and then actually just letting it start up again. So I've got another one setting up here. Anyways, I hope this was helpful. I hope that you get a lot of value out of this. And let me know in the comments if you want to see other videos. I will be making a lot more videos on more advanced use cases. I'll focus on machine learning, things like data prep. Anyways, thank you for watching.